This is a revision resource for reflection, refraction and lenses. Reflection. All waves can be reflected. Sound waves are reflected off walls or buildings. Dolphins and bats use infrasound, which is reflected. Radio waves are reflected within the atmosphere. Light waves will reflect from shiny surfaces following the laws of reflection. 1. The angle of incidence equals the angle of reflection. 2. The incidence ray, the reflected ray and the normal are all in the same plane. So that's a diagram of reflection. Refraction. Refraction is the bending of light ray at a surface, for example, when entering or leaving a glass block. The light travels from air to glass. The direction of the ray bends towards the normal. The angle of incidence is larger than the angle of refraction. All waves are refracted at the boundary between different materials. Refraction occurs because the speed of the wave changes as it passes through different materials. When light travels from a less dense material to a more dense material, it gets slower, and when light travels from a more dense to a less dense material, it speeds up. That is the refraction diagram. And lenses. There are two types of lenses. A converging wave or convex lens is fatter in the middle. A diverging wave or concave lens is thinner in the middle. Converging lenses are used to form images in telescopes, cameras, projectors, binoculars, and our eyes. Rays of light that parallel to the principal axis of converging lenses are refracted onwards. The distance between the centre of the lens and the focal point is called the focal length of the lens. The fatter the lens, the shorter the focal length. And that is another diagram of lenses.